In this video, we're going to look at the different options we have within Aspire for importing and exporting 3D data. I'm going to start by looking at all the ways we have to import data to create a 3D component. Then we're going to look at the ways we can take a 3D model that we have within Aspire and export that as data that can be used in another software program or perhaps for something like a 3D printer. Let's begin by starting a new copy of the software. Before we can import an object, we either need to open an existing file or create a new file so we have a workspace that we can import it into. So here I'm going to click on the option to create a new file. We'll just set up a file which is 10 by 10. I'm going to set the XY date and position to be in the lower left corner, work with high resolution, working in inches, and we're going to hit OK. There are two icons we use to import our 3D data. These are both located on the Modeling tab, so let's come down to the bottom, click on the Modeling tab, and then if we look at the top here in the first row of icons, we have this one that is create a component from a selected bitmap. That allows us to import an image and generate a component based on the light and dark shades within it. We'll take a look at that option later. And then this icon here allows us to import a component or 3D model. That could be a file that we've saved previously from Aspire, a piece of clipart, or a 3D model that's been created in another 3D design package. There is also another option for files that were created inside of Aspire or that have been bought from the Vectric 3D website, and that's to use the 3D clipart tab. If we click on that at the bottom here, we can see the way this works is at the top we have the ability to navigate around the folders on our PC. Then when we go into a folder that has either CRV3D, 3D clip or V3M files, which is the files from Vectric 3D, then these will be displayed as thumbnails within the bottom half of the tab. Any of these we can click on and just drag into the 2D view in order to load that as a piece of 3D clipart. So if we go up to View, Tile of Windows Vertical, we can see that has been loaded there, and we can also see if we click on the Modeling tab that's been added to the component tree. Let's just right mouse click on that and delete it for the moment. If we come back to the 3D clipart tab, as well as being able to access files from our PC, we can also access files from the Vectric 3D website. If we click on the tab at the top here, as long as we have access to the internet from the PC we're working on, we can type in keywords. For instance, we could type the word duck, hit the search button. That will open our default web browser. It'll go to the Vectric 3D website and it'll display the results for that search. Now we could take any of these and we could purchase them from the site, download them and import them into the software to use as a piece of clipart within a design. Let's just click back on the local files part of the 3D clipart tab, and we'll go back to the Modeling tab. And now let's take a look at the icon here to import a component or 3D model. If we click on this, we can go into the project folder here, and you can see it'll look for these Aspire files. It'll also look for 3D models created in other programs. If we use the drop down here, we can see these listed. Aspire files are .crv3d, .3D clip, and then also you can see the V3M files listed from the Vectric 3D website. We also have the other file formats listed: STL, Rhino files, 3D Studio, and various other here's, and they're all essentially 3D mesh files, and we'll look at importing those in a moment. First here, I just want to look at the difference between a 3D clip file and a CRV3D file. We know we can save a CRV3D file, and that's going to contain all my vectors, all my layers, all my 3D components and any toolpaths I've calculated within a session of Aspire. But if we import a component from a CRV3D file, then what we're going to get is just a single component which represents the composite model within the design, so basically what we could see in the 3D view at the point that that file was saved. So if we select this and hit open, we can see first of all it gets imported into whatever size and position it was saved at. So I may need to take it, and in this case I'm going to hit F9 on the keyboard to center that in the middle of my part. and also you can see as a CRV3D that I've just got this single component. If we take a file from within the software though, and it's a group of multiple components and it's exported as a 3D clip file, then the 3D clip file will retain those individual components as information within it. So if we come up here and click on the import icon, I choose the 3D clip version of the file here. This was exported so that the individual components were in a group. Then I can hit open, and you can see the difference is that this has a little plus by it. If I click on this and just drag it up into the 2D view, just click on this, just drag it over out the way here, you can see essentially they look and act the same at the moment, but because this has the individual components in it, I can actually see those by clicking on the plus, or I could select it and click on the icon to ungroup, and I'd actually be able to access those individual pieces. Now that's only going to be the case if my 3D clip file was exported with those objects as separate components within it. So as a general rule, as you're saving files that you may want to use as clipart in Aspire, the best bet is going to be to export the 3D clip files and then use those as your clipart rather than access files that are in a CRV3D. But as you saw there, it is still possible to import the data from a CRV3D file. It's just that you're going to get it as a single component, even if it was previously multiple components within the file. If you didn't have a 3D clip file, you could always open the CRV3D in another session of Aspire and copy and paste the individual components from it into the current session you're working in. Let's go ahead now and just select everything within the 2D view there. We'll just drag a box around it, hit delete on the keyboard. Next we're going to look at importing a model that's been created in another 3D design program and how we go about creating components from that. To do this we use the same icon as we used before to import the native Aspire files. So I'm going to come up here, click on this icon, import a component or 3D model. This time though from the project folder I'm going to select this STL mesh file called Porsche.stl and I'm going to hit the open button. Because this is a non-native file, the software will automatically open this dialog on the left that's going to allow us to adjust the position and size of the model before we create a component from it. It will also display the full model to you in the 3D view. If we maximize the 3D view and just rotate this around, you can see that the part we're importing in this case is a full 3D model of a car. Now as a component in Aspire, we can't have a full 3D object. Because everything is based on our grid of pixels to represent the 3D, we can't support undercuts, we can't have something that has a top and a bottom. So what we need to do now at this stage is to orient this model in such a way where we tell the software which part of it we want it to use to create our component. First thing to understand is that the model we've imported is at the size and orientation that it was created in the software program that it was originally modeled. So if we come over to the left here, what we need to do is adjust this orientation and this size in order to match our part that we're working in. To help us keep track, it can be useful at this stage to come to the View drop-down menu, click on that, choose the option to draw origin. This gives us this indicator where the red arrow is pointing along the x-axis, the green arrow pointing along the y, and the blue arrow pointing up in the z-axis. Now we can come and choose one of the standard directions we want here in order to start our orientation process. So at the moment it's oriented so we're looking down on the top of the model. Now these words that we've got in here just purely represent directions on the model in the way that it was actually saved. They have no concept of the fact that the car has a top, bottom, left and right. In fact, in this case, if we look at it, we could see the left of the model here would actually be looking at the back of the car. If we click on that, you can see there that the back of the car is now oriented up. And that, as I said before, is just to do with the part's original orientation from the software program it was saved in. So you're just going to look around the options you've got here to choose the correct one for your object. In this case, I would like to create a component that has the side of the car prominent in it, so I'm going to choose the option on ours for the front. So we're looking at it from the front of the model now, and that's now up in the Z-axis. As well as choosing the direction, we can also choose to rotate the object around the Z-axis. So we could click different options here in order to move that around there, and again that's just to help us get the orientation. We could, if we wanted, do this after we'd imported it. As well as these standard directions, we also have the ability to interactively rotate this. That means if we wanted to put it at an angle rather than looking specifically at one of these directions. By default, this is set to rotate the view. That means if I click in the 3D view and move this around, you can see that our origin moves and our grey plane moves as well. So that's showing me that I'm just looking at this from a different direction. If I choose one of the other options here, you can see that's going to rotate the model as it says underneath. So if I click XYZ rotation for the model and now click in the 3D view and move the mouse, you can see the origin and the plane stay in the same position, and I'm actually moving the 3D object itself. As well as rotating in X, Y and Z, you might want to fix the axis of rotation, so we could click this to rotate around the X axis only. We could click this to rotate around the Y axis only. Or we could click this to rotate around the Z axis only. And again, these just help us to get it into a position which is not one of the standard directions we have at the top here. If you do want to go back to the standard direction and ignore the interactive rotation you've made, you can click any of the options up here. So if I click on top, that'll just reset the model there. I can click back on front and you can see that I no longer have any of this rotation applied. So at this stage I've chosen front because that's the direction that I would like to import the model in here. Everything else is set, and we can come down and start thinking about the size of the part. The actual dimensions of our 3D model are shown in this model size area of the dialog here. Right now, if I look at this, I can see the units are set to inches, and this part is a little bit over 14 inches long in the x-axis as it's currently oriented. Now my job is 10 inches by 10 inches, so this would be too big to fit. So I'm going to scale this down. It's important to note that this grey plane is no indication of my work area within the software. This is just a divider, and you'll see how we use this in a minute. So don't get confused that this part would fit inside the work area as you're looking at it. You have to make sure you check the actual dimensions themselves. Now with lock XYZ ratio checked here, I'm going to change the X value to 9 inches so I know it will fit. That's automatically scaled the Y and the Z axis values, so if I hit apply now, that will change the size of my model. You can also uncheck the lock option if you wanted to independently edit any of these sizes without the other two being automatically scaled. Towards the bottom here, we need to make sure we're using the right units for our model. We can click between millimetre and inches. We also have the ability to click on the button here in order to scale the size by 25.4 or back down by 25.4 again. You just need to make sure that you've got the right combination selected for your particular part. Once the model's been oriented and sized, then we need to choose how much of it we want to convert into a component. This is done by positioning this grey plane that we referenced earlier, which is called the 0 plane. We can do that with the slider bar here, so you can see I can move it relative to the model so that it's cutting it in different positions, or we could hit the middle button to put it so that it's directly in the middle in terms of the Z height of the part. We could click bottom so that it goes to the base of the model. Now everything would be converted into my component, so I'd get the full depth of my 3D model. Or I could indicate a value, so maybe I just want the top 1 inch, so I'd type in 1 and hit the space bar in order to position that now so that we can just see the top 1 inch of our 3D model sticking out above the 0 plane. In this case, I'm going to click middle, set that back there so that it's in the center of the part in terms of the Z-axis. In addition to that, we have some other options we can choose here that'll define whether we keep all or part of the model. If I say discard data below zero plane, what that will do if we hit OK is just create a single component which has just got the model above the zero plane in it. So everything below the zero plane would be eliminated completely. Typically the only time you'd want to uncheck that is when you've got a model that's inside a dish or a recess, so in effect it's got like a negative component relative to the plane that you want to make sure that you actually created as part of your component. The center model button would allow me to reposition my entire model so that the datum position is back to the center of the part. The X, Y and the Z would now be in the center. That can be useful for you if you've been doing a lot of rotation or manipulation of the part so that maybe it's got slightly out of position. The last option here is to create both sides. At the moment, as I said before, we just create the top side of the part, but it may be that I'd want to create this model and have a component that represents what's above the plane and a component that represents what's below the plane, so that I could then slice that up in a spire in order to create a full 3D object again by then cutting and reassembling those pieces. So I'll show you that option here. We'll click create both sides, hit OK. What the software will do is create two components for me. This will now look a little bit odd in the 3D view here. If we go up to view, tile the windows so we can see both the 2D and the 3D, you can see I've got one component that represents the top that was above the plane, one component that represents the bottom that was below the plane. If we just select that, I'm going to hold the shift key down and drag that down, then you'll see that we were just getting the two components adding on top of each other, which is why it looked a little bit odd in the 3D view. Now if we wanted to, we could rotate that 180 degrees, hit apply so that it's also the right way up, and then we might take both of those and just center those in the middle of our part. So a couple of things to notice. I'm just going to switch off the bottom one here and maximize the 3D view. So we talked about before, we've lost all the undercuts, so the area underneath the wheel and also you can see the area under the aerial have just been made into a solid piece of material. There's nothing we can do about that because we have no way of supporting an undercut in a spire. In most cases that's absolutely fine as well because we can't machine those undercuts either with a 3-axis machine. Now, once we have imported any file into the software and created a component, then we can work on that component in just the same way as if it's something we'd actually modeled directly in the software. So as you saw there, we could take it, rotate it, and we have access to all the other modeling functions and editing functions to manipulate this as well. So if we wanted to, we could tile the windows, I could zoom in here, and may come down to the drawing tab and just sketch a line in here in order to put a bounding box around that aerial. Then we could select the component, shift and select the box, come back to the modeling tab, click on the option to crop that area from inside the box. You can see we've actually edited the model itself. We could even go in there now if we want and use the smoothing and sculpting tools on this in order to try and smooth out some of the facets we've got. And this faceting that I just mentioned there, this sort of triangles that you can see on the part here, were already in the model when we imported it. That's how the file was saved, and this is fairly common in parts that you may find on the internet for download that are in these mesh formats. If you're creating the parts yourself in another design package, then you can normally control this by what tolerance you set when you actually export the part. So now we've looked at the different options for importing either 3D files that have been saved from a spire or importing 3D models from other software programs. Let's take a look at how we can open a 2D file and create a 3D model from that. I'm just going to go up to the tile windows vertically here, switch on both our components, select these from the 2D view, hit the delete key on the keyboard, and now let's go up and click on the icon to create a component from selected bitmap. We click on that, I can go and browse for image files, and you can see in the project folder we have a few of these that we're going to show you. When I click on one of these, what the software is going to do is create a component. The white areas within the image will be the highest part of the component, the black areas will be the lowest part, and all other shades in between will be assigned a height and just interpolated based on how light or dark they are. Now this is very good if you've got a specially prepared image like this flare we've got here, where the white has been designed as the high and the black has been designed as low. If we select this and hit open, you'll see that we'll actually get quite a good clean model that we can work with, albeit with this additional flat plane in here. However, most images we work with are just going to be our normal digital photo or things that we've scanned. So if we delete this and show you those, let's just click back on the icon here. These will give us a result, but there are a limited number of applications that we can use these for. If I click on this photograph of a house and hit open, I can click on this, I can select it, we can rescale it once we've brought it in here. So let's make it 9 inches, hit apply, close, and then we'll just hit F9 to center that. And we can see that's quite noisy first of all. There's normally a lot of sort of what's best described as noise within an image, so we could help that a little by smoothing it. If we click on the smoothing filter, just smooth that out a little, you can see we can mitigate some of the noise and hit OK, and that looks kind of okay. But all this has done is effectively created a texture. We're not going to be able to carve this and see the same thing that we'd get if we actually created a proper model of this house as a 3D relief. I can really show you that a little more clearly by scaling it up. If we take that component and perhaps make it say 3/8 of an inch high and close and maximize the 3D view, you can see it still looks kind of recognizable there, but really this is not something that we're going to be able to use to carve to create a 3D model of a house. The reason I show this is because this is quite a common misconception with the software, is that you can just import an image and generate something that's the equivalent of somebody creating a relief model. What this is useful for though is creating a texture that we may be able to apply over the top of a 3D model, or to create a texture for a background. So if we take this component and delete it, let's come back, tile the windows and import the other image here, this post, and hit open. We'll see this is a wooden post that's got kind of a weather beaten look to it. We can scale that up, can hit F9 to center it. Again, we might want to take that and just use the smoothing in order to knock out some of the noise. Hit OK. We might also want to scale that down a little from what it was automatically scaled to. Let's put in a value of 0.08 of an inch. Hit the space bar and close. And you can see what that's done is created quite a nice texture for us. We could take that, put it into the background of a sign or some kind of design. Perhaps we could take the component, shift and select that rectangle that I've just sketched there, go onto the modeling tab and just say we want to clear the area outside of our rectangle, and there you can see we've got a nice texture that we could use and put into the background of a sign to create almost a kind of a sandblasted or wood grain look in this case. So there's definitely some useful potential with importing images, but it's also important to understand some of the limitations. One other note on importing images is it will depend on the type of image as to the quality you might get into the model. When I import, if I import a JPEG, a bitmap, a GIF or a PNG, then that's only going to find 256 Z levels from the model. So if I've got a lot of shallow curves on something, as I scale them up and down, I might actually see stepping in it. If the file's been saved as a 16-bit TIFF, then the software will interpret up to 65,000 levels in that, and so you'd get a much smoother model. But those 16-bit TIFF files and this kind of grayscale file tend to be extremely specialist files that have been specially prepared as a kind of grayscale height map. One application you will see that uses that is making terrain maps, and that's quite an interesting application for the software, and you can find information about that on the Vectric user forum. Let's just cancel this now. We'll select that component and hit delete. So you've seen there a number of ways that we can import data into the software to create a 3D component. We also have ways to export our data as different file formats. Typically in Aspire, the end result is to go ahead and take your 3D models and your vectors and create toolpaths with them and output those to the CNC. In some cases though, you may want to save your 3D data. One application, as we've already seen, is to save the files in native Aspire format so that you can import them back into the software and use them as pieces of clipart in other designs. You may also want to export the data as another format of 3D model though, in order to take that into another design package and use that as a part within another software program. We can also take our 3D data and export it as an image file, and that may be something you'd want to take and output on a laser, or it may be something that you'd want to take into a photo editing program in order to use some of the manipulation tools in there, then to resave it and then re-import it back into the software. These are fairly specialist applications, but I am going to show you the techniques to export different types of files now. Let's start by actually opening a file. So I'm going to say File, Open, and from the project folder I'm going to select this CRV3D file, F02, and hit Open. I don't want to save what we've currently been working on. I'm going to tile the windows vertically. We can see because we've opened this CRV3D and not imported it, that we've got the individual components from within the part. As we saw there, if we imported this CRV3D, we'd just get this as a single object. If we don't want to just save this as a CRV3D, but we'd actually like to take it and export it as a 3D clip file, then what we'd need to do is group together our components. So let's select the top one, shift and select the bottom one, click on the icon to group them, and then I could right mouse click on this and choose the option to export as 3D clip art. What that's going to do is take my group of components, it'll let me give it a name, save it as a 3D clip file, and as we saw earlier, we could then import that and it would retain the individual components within the group that was imported. So typically the 3D clip file format is more powerful if you're trying to save objects for use in other sessions of the software as a piece of clip art. Either of those files though we know could be browsed on the 3D clip art tab. In addition to saving this in an Aspire file format, we could also take any set of 3D objects within the software and export them as an STL or OBJ mesh. It doesn't matter whether your objects are grouped or not grouped when we do this, all it's going to use is whatever's visible in the 3D view. So if we take these, right mouse click and ungroup them, we can see we have a bunch of components. Whatever we currently have visible, when we click on the icon here to export composite model as an STL file, is what the software is going to use to generate the STL mesh. We're going to define the quality of our mesh by telling it either a tolerance that it's going to use or a maximum number of triangles it's going to generate. If I enter a value of 1/1000 of an inch, 0.001, we can go ahead and hit the triangulate button here, and the software will display the mesh that it would output if we hit save now. If I maximize the 3D view, we can zoom in, you can see the faceting within that. We can also view that as a wireframe. If we uncheck the box here, you can see each of the triangle faces that would be created in the model that we're exporting here. Let's just check that back on. If we make this value smaller, then we get a finer mesh. So if I put that down by another decimal place, you can see now it's very, very hard to see those triangles unless we zoom right in and perhaps undraw this. So we've got a much denser mesh, but that would make a much bigger file in terms of memory size. As well as controlling the quality of our mesh by using the tolerance or by defining the maximum number of triangles we'd like to have in the part, we can choose how we want to close the part off as well. The default here to leave open, if we click and rotate this around, you can see that basically this has just hollowed out in the back here, so we've got an infinitely thin skin. If we choose the option to close with an inverted front, then we get a copy of the top on the back, and so we create a full 3D object here with two sides that are the same, top and the bottom, which are exactly the same. Or we could choose the option to close with a flat plane, which will just give us a flat back there. And these last two options are the type of things you're probably going to choose if you're going to send this to a 3D printer, because it's going to normally work better if you have something that is completely sealed off. Once we're happy with all the settings we've used, we can see visually that the part looks correct. Then we can come down and click on the button to save triangulation. We could choose to save it as an STL, a wavefront object, or if we wanted to create a shading, a special type of shaded file, we can choose the POV Racine option. Typically, we're going to go with something like the STL file. We'll give it a name and we'll hit save in order to save a copy of that onto our hard disk. Once we've saved the file, we could then put that into a program that supports importing an STL mesh, or as I say, we could take it to a 3D printer and we could actually print a copy of this file. Let's go ahead and hit close now. The other method we have to export our model as a 2D image is to again make sure we've got the object that we want to export visible in the 3D view. So whatever we can see as our composite model is what's going to be exported. Then we come up to Model on the drop down and click on the option to export as grayscale bitmap. We have a variety of choices we can export here: bitmap, JPEG or GIF. We'll export a grayscale that has 256 levels in it, or if we choose the 16-bit TIFF option, that will export a grayscale that uses 65,000 different levels of grey. That is obviously much more accurate and smooth if we choose to import that back into the software at a later stage. Whichever one we choose, we just give it a name, hit save, and then we've created, in effect, what is a 2D representation of the 3D file. Any transparent areas in the image, like we can see in the modeling plane here, will be exported as black, and then all the heights within the model will just be exported, so they're interpolated from white at the highest points down to black at any points which are at the bottom of the part. So before we finish, let's take a moment to summarize some of the things we've looked at in this example. We started by looking at all the different ways that we can import files into the software to create a 3D component. That includes files that have been created previously in Aspire, the CRV3D and the 3D clip files, as well as the V3M files from Vectric 3D, and we looked at how we can access those through the import icon as well as through the 3D clipart tab. We then looked at importing files from other software programs, such as an STL mesh, and we showed you how that needs to be oriented and sized and positioned in order to import which part of that model you want to create your 3D component. We also saw how you can import a model, a full 3D model, and create both sides of that object as 3D components within Aspire. Next, we looked at how we can import a 2D image and convert that into a 3D component by having the software interpolate the shades within that, the dark areas being the lowest and the light areas being the highest. Then we went ahead and looked at the ways we have for exporting 3D data from the software. We saw how we can take it, save it as a CRV3D, as a 3D clip file to use as a piece of clip art, or how we can export it as an STL mesh in order to take that into another software program or to export to a 3D printer. Finally, we looked at how we can take the objects in the 3D view and save them as a 2D image. And that concludes this video.